Today, what we will cover is not ESCOM. We will try to look at the population, the units of analysis, the representative sample, the sampling bias, the sampling error, and all those that go with that. The last time when we met, really, we tried to look at the issues of population. And we said we will have a lot more time to discuss the different types of sampling strategies. This is done so with the view that as students of research, you're now taking your proposals and you're putting them and you're really checking and correcting or improving your own proposals as we go along. So hopefully that's what you will do. So you will then look at what did I say as a student in relation to my area of population and my area of sampling in my proposal. So we will try to navigate more in detail sampling so that everybody, when we're done with this subject, should then be able to do sampling in a relatively easy way. So hopefully today, that's basically what we will take home as the outcome of the session. A population, once more, ladies and gentlemen, it's a group of usually of people about whom we want to draw conclusions. I was reminded earlier today where we were by a colleague of mine that you can actually have a visual demonstration of a population by using simple practical examples that stick in people's minds more. And it was at a time when we were at the complex and somebody came to us and said, do you want to sample this coffee? Now it then immediately crossed my mind that every day we come across population and sample, and we just don't realize it in a much more technical way. Now, what the waiter was saying was, you sample the coffee from the population, which is the whole box of coffee or the whole container of coffee. So the whole container of coffee, see it as a population. So in other words, the universe of units that we were looking at. And then he said, sample the coffee. So what then is what was meant by that is that which you are drinking from a small cup. It's a sample of what the total coffee is going to look like or taste like. So when we then sample the coffee, we realize very soon that, oh, this is the container. If you want to buy it, this is what it is. So in other words, you have sampled it because it represents the total population. You drank it, and then you know how the entire population, tastes like. So in other words, what I'm trying to say to you, ladies and gentlemen, is that the whole container is the whole population. So when somebody gives you a sample, it's saying, taste this, because if you like it, you take the whole population. So in other words, the small coffee that we are tasting was a sample of the total population. So therefore, it was representative that whatever you taste there is what you will taste in a bigger container. And that to me became quite a very profound example of how we can look at the population when we say it is a people about whom we want to draw conclusion, or the universe of units like people, nations, cities, regions, firms, etc., from which a sample is selected. So you take an orange from a bag, you chop it into small pieces, and people taste it, and you say if they are palatable, if the taste goes well, they can buy the whole bag. Now then they know this bag is a population that is represented by the sample that you tasted. I couldn't see any other example that defines the representative sample better than that. So a population, therefore, is a term that sets boundaries on the study unit. So if we're going to study a particular type of citrus fruits or of coffee, then the entire coffee field becomes a population. So it refers to individuals in the universe who possess specific characteristics when you look at the social science and people being of concern. So a population then means the group or collection that you're interested in generalizing about. So I look at the group or the collection that I want to generalize. I want to bring generalization on. It is very common that people generalize on biasness or on stereotypes, or I mean we generalize a lot. I can think of the common generalization that we have. I mean, Nigerians are drug dealers. There's many generalizations that we do, some of which are not necessarily based on the fact that we have had a sample representative of anything, but more as a manner of speaking, some of which can be very harmful, of course, but some can be quite misleading in many ways. So when you look at the total collection of units of analysis, you look at them in the population. So you take the population and you get the units of analysis from the population. What are units of analysis? Units of analysis are elements of the population, whether individual or groups, organization or events, artifacts, social interaction. So in other words, when we talk about units of analysis, we're talking about the what we want to study or whom do we want to base our study on. So as we said the last time, in social research, the most typical units of analysis are individual people. There are those things we examine in order to create summary descriptions of all such units and explain differences among them. So we look at the entire population, and then we identify those things that we want to examine in order to create the summary descriptions of all such units. So they represent the entire population, and then we explain the differences among them. So that's basically the units of analysis. Basically, like, what is your target? What is it that you're going to base your summary description on? Or what is it that you're going to explain as differences amongst them? So you look at the population and you say, what are you interested in the population? So that then you are able to explain or to create that summary description of all such units in the total population. I'm not sure whether there's a question up to this point, but I hope that the introduction has been quite clear for most of you to catch up. Now, the most important thing that we spoke about and we would like to repeat now is, before you do a sampling, there's something we call sampling frame. And again, when you look at the sampling frame, ladies and gentlemen, it's not something that you sometimes put in your research proposal at your postgraduate level, but it's ideal to put a sampling frame, because what the sampling frame does is that it provides a listing of all units in the population from which the sample will be selected. So what you do here, you list all the elements, all the units in the population, so that then you know when you're going to select the sample, you select from all those units in the population. So a sampling frame is the list or a quasi list, your own list, some kind of your own list, quasi meaning something that look like a list of elements from which a probability sample is selected. So what you do is that you go to a population, and you list all those units that are in the population from which you are going to sample, you are going to select your sample from. So if, for instance, you are going to focus on schools, you then go and say, what are the units in the population that sort of characterize a school, in order for you then to come up with a sample that you will then select. So basically what you do there is that you create that list. So that list or that quasi list of units composing a population from which a sample is selected. So when I look at the list or at the sampling frame, I should then be in a position to see the totality of the population. So basically, you sort of just put everything in the population down in a form of a list. So that's what the sampling frame is. So if the sample is to be representative of race, it is essential, really, that the sampling frame include all or nearly all members of the population. So if your interest is to come up with a representative sample from the population, then you need to have all the members of the population into your sample. Then when I look at the sample, I should then be able to see the entire population. So basically, when I look at you are mirror the sample of the total population. So you look at the sample and you know this is what the total population looks like in real life. So basically, that's what it means. Sampling frame. It's important to have a sampling frame at the back of your mind, or as you go into your study, just so that you make sure that you've got your population in totality understood. Now, there was a question some time back as to how big or how small should a sample be. And once more, I just want to caution you that this is just a guideline. So that then means that between you and your promoter, you can get some kind of a general understanding. But it's important just to understand the issues around how big or how small should a sample be, just as a general rule. So the following guidelines are for selecting a sample size, and these are just guidelines by different sources. So you're welcome to look at different sources also to come up with your own understanding, but also engage your promoter in that regard. For instance, for a smaller population, such as, say, for instance, a population of 100 or fewer, there's little point in sampling. You can survey the entire population. So you take the whole 100 and you survey all of them, because that population is small enough that you can look at all of it. Now, if the population size is around, say, for instance, give or take 500, you can sample 50% of the population. 50% of the 500 could give you 250. Now, this is talking to numbers. So this is really in the quantitative space that we are talking about, because it might be very difficult in your proposal to interview 250 people. If the size, for instance, is around 1,500, you can do 20% of the sample in there. That gives you about 300 or so, of the population that you can sample. So remember, a sample is a representative of the population. So if you have done the sampling frame, the 300 could really look like the 1,500. However, beyond a certain point, such as, for instance, a population size of 5,000 or more, the population size is almost irrelevant at that level. And a sample size of 400, therefore, can be adequate. So if you've got 10,000, 5,000, and whatever, you are welcome to look at around 400 as a sample size to generalize from a representative sample in that regard. So it's up to you, ladies and gentlemen, to look at your population size, and based on the population size, you then come up with the sample that should be representative of that population. But these are just guidelines, as we say, 100, what you can do all of it, 500, for example. So this is just to guide you in the work that you'll be doing. Now, what then becomes a representative sample? This principle is crucial for research studies, because you are going to realize that very soon, that for every probability study where there is an opportunity for you to generalize, you need to have a representative sample. What does that mean? That means a sample that reflects the population accurately. So you take the population, and when you see that there's every element of the population that is being taken care of, you are well within your right then to generalize, because you've got the representative sample. So if you want to be able to generalize findings to the whole population, the sample needs to be a representative sample. So if your intention is really to generalize to the entire population, that you can make conclusions that affect all the members of the population that you are studying, then it is desirable that you do a representative sample. So sample is representative of the population from which it is selected if the aggregate characteristics of the sample closely approximate those same aggregate characteristics in the population. So that quality of a sample of having the same distribution of characteristics as the population from which it was selected, that gives you a representative sample. By implication, descriptions and explanation derived from an analysis of the sample may be assumed to represent similar ones in the population. So representativeness is enhanced by probability sampling, and it does provide for generalizability and the use of the inferential statistics. So representativeness in this case is quite important, especially within the probability sampling type of design that we are talking about.
Okay, thank you so much. What I wanted to ask, Prof, is that if, for example, you want to take a sample population and you want to maybe say, I'll just make an example, high school students, Black high school students, I don't know, are drinking too much. Let's say that. So my question is, that's a big generalization. And if you are doing research, for the person that's going to be reading this research to now and in the future, how do you draw the line between not going too broad and being too specific when you're doing your research and doing the sampling size, without being offensive? Like, where do you draw the line with generalizing?
If you want to generalize and say high school students, I'm not sure whether I understood you, or high school students or basic, I don't know what is the category that you want to go to. For you to get to a point where you generalize, then you need to first have a representative sample of the students who drank, isn't it?
Yes.
So I'm saying, what is the category that you want to focus on? What is your unit of analysis? Is it high school students or which students? Because remember, you first have to identify the units of analysis. Let's take that as the point of departure. Where do you want us to start?
High school students.
So if you say high school students, the first problem that you are dealing with here is how many high school students do we have? They probably runs into thousands and thousands, right?
Yes.
So do you really want to look at high school students that run into the thousands and thousands, or you particularly looking at as high school students in a particular say, for example, a geographical location as an example? You see what I mean?
Yeah.
So you need to narrow it down. You need to narrow it down and sample it in a particular, I would even say particular area, location, so that you generalize to that population before you could start talking about high school students as far as Enyobe in the Eastern Cape, for example. So you need to say what is, if you go to the department, is it basic education? I think is the one. And you ask them, what is the total population of high school students? And assuming high school starts from what grade? Grade 8 to grade 12. It might be that you are not looking at grade 8 to grade 12, right?
Yes.
Are you following the the discussion, Ed?
Yes, I am.
So what are you looking at? So we can narrow it down and say, what are you talking about now? Because we want to see what is it that you want to sample from. You have to sample from a population. Now I'm saying, if your population is high school students, you've got a huge challenge, because there is about, I'm saying, thousands and thousands, maybe even millions. I don't know how many high school students are there in the country. That's the first challenge. So what do? We can probably narrow it to what?
Maybe
So
from grade 10 to grade 12, because research from DBE has shown that most students drop out of school in grade 10.
maybe you narrow it from what?
Grade 10 to grade 12.
Yeah, again, if you look at grade 10 to grade 12, you're talking huge numbers of students, right?
Yes.
I mean, grade 12 this year might just be 1 million. And then how many are grade 11? How many are grade 10s? And where about are we talking about? Is it in South Africa, in the whole of South Africa? I hope you're following.
Yes, okay. Thank you.
So for me, well, I'm not sure why you are now jumping out of the conversation.
Yeah, I'm here, Prof. Just got cut off a bit, but I'm here. But let me
Okay.
give
No, I want
Moji
you to reflect your understanding. What is your understanding?
So my understanding now from what you're saying is that it's important for us to narrow down our population size when we do sampling, because if we go too wide, then it's going to create problems. The research, the scope of the research will be too wide. So what you're saying is we need to narrow it down in order for us to find a sample size that is representative of that geographical location, so that you don't generalize too much.
Yeah, so I want us to see if we can narrow it down, because you've now narrowed it down to 10 to 12, grade 10 to grade 12. And I'm saying, is it not still broad enough?
Okay, I think it's still broad, because
yes.
we are speaking about 3 different grades. Yeah, so I think it's still too broad. So I need to
actually, even if you were to use one grade and grade 12, to me it will still be broad.
Okay.
Because then you need, I'm not sure whether you want to have a sample of 1 million in the country. So it will still be broad if you say grade 12, just taking grade 12 alone. So you could still say grade 12 whereabouts. So you can also do a geographical location. So maybe you're talking about the school in a district, in a region, in a province, and so on and so on, if you get where I'm going with this.
Yes.
So it's important to first start with a simple problem in a simple way, so that then as you broaden it, you've started from the simple to the general. Remember the inductive and the deductive logic. That sometimes it's very important to start from a specific to the general, rather than the other way around, because then it's a researchable problem that we are interested in.
I just wanted to find out, because this is the problem that I also had with the previous student. I just forgot her name. Then does this mean that your it has to be specific? Because that's what I'm struggling with. If you're saying you're narrowing something down, does it mean that it has to be specifically grade 12 in this particular area? And also, how many of those grade 12, does it have to be specific? That's the question that I'm asking. Does it have to be straightforwardly specific, if there's such a word in English? But yeah, because this is what I'm struggling about. If you want to narrow down, how far do you narrow down? And how do you know whether what you have narrowed down, will it be enough? Will it be enough for what you want to bring about? Or yeah, that's my question. I don't know if I've asked it in a way that you would be able to provide an answer.
No, I'm not sure what. Look, it can be broad, but the specific problem gives you a better focus of what you are looking at. For instance, it doesn't have to be grade 12. It can be grade 10, it can be grade 11, it can be a combination in a school, for example, a school, local school, for example, right? So you can look at grade 8, is it 8? I think it is, from grade 8 to grade 12. But also there, you could be, specific on, is it boys, is it girls, is it everybody, is it for this ages or that ages? But it's the more specific the problem, the better that you'll be able to research it than when you've got a complicated problem where you're looking at, schools, for example, there's more than 25,000 or so, I'm told, schools in the country. Now, if you're going to study 1 million plus matriculants, I'm not sure what kind of resources are you bringing yourself as an individual researcher. Whilst it could be practical and feasible and convenient to look at perhaps the local schools that you are close by and do a particular survey there. So I'm not sure what will be the idea behind wanting to study everyone. Because remember, we said when you do research, you must also look at practicality and feasibility of your research. So all we're saying is, if I have to study university students, it's not the same with me studying UNISA students in Johannesburg. Because then I've got the problem of all the 26 universities plus and the private universities and so on and so on. And there's issues around accessing the population, the sample. But if I'm studying UNISA students in Johannesburg, I've done a very specific geographic choice that these are the students in Johannesburg that I'm interested in. It could be students somewhere else, as an example. So you will still have findings, some of which can still be checked against other students elsewhere, because there's a word that we use sometimes in research, which is extrapolation. What is the extent to which we can extrapolate the findings to other students? So but for me, you first do deal with what you are confronted with first before you can complicate your research study. So I'm not sure. The long-winded way was trying to answer the question.
Yeah,
okay. Thank you, Godfrey.
You answered me because I wanted to know, do we need to be specific when we do that, the research, and how far, how specific do we have to be? So yeah, I think you answered me.
Oh, okay.
I actually wanted to find out, you have to make it that broad. At the end, would you be able to draw conclusion of the overall? So once you said the way that you use exploration, whatever, I just Googled it and I think
let's use it properly. It's called extrapolation.
Okay, yes. My issue was around there to say if
I think as a researcher in one of your meetings, you need to say, how do you extrapolate the findings from the University of Western Cape to our environment? And I'm sure it will sound like really you are now a student of research.
Okay, let me start
now. Because you have to use
extrapolation.
We have to use these words. Otherwise, what is the use of studying when you don't use the ways that are like sampling? You need to check with what was the total population that we're working with. It sounds very good, and I think as students you need to start becoming more generous with the concepts so that they stick in your day-to-day conversation as well, because it's appropriate. There's nothing wrong with asking a person, but what was the total population that we are working with here, and what was the sampling strategy that was employed? So now it sort of just sit well. Angela, so you need to don't throw it away like that way, because then you're not gonna remember it. It's extrapolation.
I hear you, Prof, and I agree with you. Thank you so much. Next time I'm going to say extrapolation.
No, use it. Yeah, just to say what it does is you can have research done with a group of people or you students at the University of KZN, for example, or any other institution, and somebody wants to use that at the UNISA Johannesburg with all of you. So basically, you just want to see the extent to which some of those research results can be applicable under different circumstances. So we have to use those words. Otherwise, then, I mean, why are you paying your fees for? Let's go to sampling bias and sampling error. As a researcher, you're always going to have a distortion in the representativeness of the sample that arise when some members of the population that is in the sampling frame, remember that sampling frame, that list of the units in the population, stand little or no chance of being selected for inclusion in the sample. So you're going to have that list and you feel like, you know what, I'm not going to include this kind of students in my list for whatever reason. So you will have your own bias as a researcher. So that is what a sampling bias is. We all do have sampling bias, you know. You feel that no, I'm not going to include this one. I'm not going to do the, you know, but they are there in the sampling frame, but you choose not to include them. It's like looking away, kind of, you know. So sampling bias, you may have it also in your study. It's something that you should just be aware of. And when you do your proposal, you just need to, if you have been, you raise it because it's always there. So you are human yourself as a researcher. So it's acceptable in research that there will be some level of sampling bias. What becomes a problem is one, you don't mention it, or two, when you've got a lot of it, then it becomes a problem. But it will always be there. So there's nothing wrong with a sampling bias being mentioned. Sampling error, you know, it's about, like, for example, for probability sampling, there are a number of errors that we can think about. One is the sampling size. Sometimes you know there was 100 people in the population, and you only dealt with, for example, 20 of the 100. When dealing with all of them would have been a better way of enhancing your study. The diversity of the population. Sometimes the population is so diverse that you are not able to deal with its diversity in totality. So it's too diverse for you that you feel that you're not going to chase all the diversity, the confidence level. Sometimes as a researcher at times, or even, that when you go around and collect data, you have got your own confidence level as well. So those are just some of the factors that may affect your sampling, and they're part of the sampling error. So it's important, ladies and gentlemen, to understand these things, that they will happen. And when they do, there's nothing wrong with them. All you do is you note them and you report about them. It's like a self-critique in research, that you criticize your own sampling biasness. You raise your own factors that influence your sampling employment that you used in your research. So it's acceptable in research. Sampling design. It is only when research results generalizable from a sample of a population that the results have meaning beyond the limited setting. So in other words, if you are going to have to generalize the results of your research, your sample from the population really has to be representative. Then the meaning will go beyond the limited setting. So if you're talking about the school situation, if you go to a particular school, let's call that school X, and you're focusing on grade 12, for example, and you sample from the grade 12 that happens to be, let's suppose there's more than 500 grade 12 students in a particular area. Then you have taken your 50% of the grade 12, which gave you 250. Now, if that 250 is a representative of the 500, then you can generalize your result to the 500, because the 250 represent the 500. So sampling is the selection of research participants from an entire population. and it involves decisions about which people, setting, events, social processes are to be observed. So when you've spoken to the 250, they then speak for reasonably, they represent the 500. So there's no need for you to talk to 500 when you've got a representative sample. There are two types of sampling, ladies and gentlemen. We spoke about them: probability sampling and non-probability sampling. Probability sampling is determined when any element or a member of a sample is included. Now, with probability sampling, it's almost like all elements or any elements or a member in the community, in the population, stands a chance to be selected. So we all stand a chance to be selected insofar as probability sampling is concerned. Non-probability sampling is any technique in which samples are selected in some way not suggested by probability theory. So basically, non-probability is the opposite of probability. So not everyone stands a chance to be selected in a probability sampling. So the basic rule in sampling is the larger the sample, the better. So it's always better to have a larger sample to select from than a small sample, because then you stand a chance when you've got the larger sample to get more data than when the sample is too small, because then there is those issues that we raised earlier on. Let's just look at probability sampling. Probability sampling, just in details here, it's a sample that has been chosen using random so that each unit in the population has a known chance of being selected. If I look at you today, all of you stand a chance to participate in this class, as you all have an equal. So there's an equal probability of all of you participating, because there's no predetermined methodology that is been followed, for you not to participate. So all large-scale surveys use probability sampling methods. So all large surveys, if you're going to sample from 5,000 and 10,000, it's really sensible that you use probability sampling method, because then you are able to reach as many as possible. If I then today was to sample 2,000, it's ideal that I just, I use probability sampling, because then I can reach as many people as possible than non-probability. So probability sampling, you can already see that we're talking huge numbers, which is already you can start thinking quantitative as opposed to qualitative, because numbers matter. Because remember, the issue here is that you're trying to get representativeness of the research sample. Application of probability sampling involves some sophisticated use of stats, and it's understandable why the logic of probability sampling is that if all members of a population were identical in all respects, in other words, if people were the same in all demographic characteristics, attitudes, experiences, behaviors, there will be no need for careful sampling procedure, because then whatever you see in Annele is what you will get in Godfrey. So it's really simple why probability sampling is actually not difficult to understand, simply because people have different characteristics, attitudes, behaviors, experiences, that are different at all times. So in this extreme case of perfect homogeneity, in other words, where people are the same in all respects, any single case would be sufficient as a sample to study, because then you don't need, you don't have to worry about the whole population, given that the single case will give you exactly what the whole population represents. So in order to have a random sample selection method, you need to put in some process or some procedures data shows that the different units in the population have equal probabilities of being selected. Now, you need to have that kind of a procedure where you then set them up in such a way that we all have a chance or equal probability of being selected. An example that we can think about is picking a name out of a hat. If I say to you, write your name down, cut your names and throw them in the hat, and we sort of just shake it a little bit, each of you names has got a probability of being selected because it's random. So we throw them in the hat and we can pick them up anytime we want to. Now, you all stand a chance, unlike those whose names are not there. So with random, it's just random. We just throw it and then we see what comes out. So a representative sample is more likely when this method of selection is used. So you put your name, all of you, throw them in the hat, and then we pick up the name. So the aim of probability sampling really is to keep sampling error to a minimum. So basically it's to reduce the error so that you don't have a lot of errors in your sampling strategy. There are different types, ladies and gentlemen, of probability sampling design. So you don't simply say, well, I'm going for probability. You need to say you're going for probability, but which type of probability? So you can have, probability sampling design, but you also have a type of that. So in terms of the hierarchy, I'm saying there are two types of sampling designs. It's probability and non-probability. But there are then types of probability sampling design. This is what we are now moving into. So there's about 5 of them. We can think about them. I don't think your question will be, oh, please mention the different types of probability sampling. But what we are trying to do here is just to simplify them, to try to simplify them for you so that at least you could navigate them as you do your proposal. The first one is simple random sampling. As the name suggests, simple random. The second one is the systematic random. The third one is stratified random. The fourth one is cluster random sampling. And the fifth one is the theoretical sampling. Other sources that you are going to study may bring others. That's fine. All what you are trying to do is for you to understand the different types of probability types as opposed to non-probability types. So in other words, what happens with some students at times is that they will choose probability sampling, but then it's not one of these types that are probability sampling. Then you begin to see the misunderstanding of the types of some probability and non-probability. So it's important for you to check, I am going to do probability, but which probability am I talking about? So it's important to first understand that. Maybe before we go ahead with each one of them, let me just check if we can pause and engage on the sampling, because this is quite crucial. As we said, the type of probability sampling, we will start first by looking at a simple random sampling. This is the one where we do it without a plan. As I said, put your names in the hat, throw them in, whatever comes out, comes out. Simple random sampling is the basic sampling method assumed in the statistical computation of social research. So this is the most simple one. So remember, it's probability, but then it comes to simple random sampling. So everybody here whose name is in the hat stands a chance to be selected, or all the SMMEs can be selected in Johannesburg. So it's a simple, you can go this way, it's like, oh, here is one. So it's basically like accidental. It's a type of probability sampling in which the units composing a population are assigned numbers. So as you walk around the population, perhaps you put a number, and when you go home, you simply say, okay, I've got 20,000 SMMEs in this area, and number 10, number 50, number 200, you select them, you can select them randomly. So a set of random numbers is then generated, and the units even those numbers are included in the sample. So you just pick names and then you put numbers on it and you can select them. So every member of the population at this level has an equal chance of being selected. Such an approach is easy when the population is small and all of its members are known. So if you've got a small population and you have assigned numbers like that, then it's much more easier. If it gets into thousands and millions, it becomes too complicated. So it's very easy to use a simple random when you are working on a smaller population size. The second type then is systematic random sampling. Here, for example, I use the example where when you go to conferences, at times we sit in there and they want to break us down into some kind of groups. And then they go on and say, you know, let's just randomly select, you know, you are number 1, then it goes 1 up to 5. Now here we can use, for example, kth, which is the letter K. So there's about J and then K, or 15th or 20 Ks from a complete list of 5. So you've got a whole list of a directory, and you only go to 1, 2, 3, 4, up to 10, or up to 15, and every kth element in the total list is chosen systematically for inclusion in the sample. So you go 1, 2, up to 5, all the 5, I take them. So that's systematic. It's random, but it's systematic because nobody would have known that they are going to be number 5 today. So all the 1s and the 2s and the 3s and the 4s had an equal probability of being selected, but they were not selected because I've systematically chosen to go with kth or something. So the sampling ratio or the sampling interval is the standard distance between elements selected in the sample, 1 to 5, for example. There's a distance between 1 and 5. And you compute K by dividing the size of the population by the desired sample size. So K is called the sampling interval. So every time I get the letter K, I take K, and then I start all over again. So the interval there is the letter K. Systematic sampling is a functional equivalent of a simple random sampling and usually easier to do. That's also very easy. All the children at school, you know, they come and I start counting them, and everybody who's K, I say stop. And then I start all over again, all K, I stop. You know, just to make it, you know, more clearer for you. So the first unit is selected at random because the first one says it's 1, and then I start counting from there. So the sampling interval is the standard distance between elements selected from a population. So it involves choosing individuals or clusters according to a predetermined sequence, with the sequence being determined by chance. So the fact that I'm going to do all K is really something that is determined by chance. Let's look at the stratified random sampling, which is the third type of probability sampling. Here again, you subdivide a population into 2 or more mutually exclusive strata or segments. You go to a community and you divide them. Retail sector, for example, SMME, they might have characteristics or strata that they work with. You know, maybe they serve upper, middle, lower class, there's medium, there's low, there's high, volumes, and so forth and so forth. Those stratas, put them together, and in a population, you basically, this is also going back to the sampling frame where you list what the SMME is all about. In other words, if the SMME is a population, you start identifying all those units in the population, the SMME population that you would like to select your sample from. So stratification is not an alternative to this method. Rather, it represents a possible modification of their use. So when you stratify, basically you're looking at strata. Like every community, every population have stratas. I mean, they are not the same. So you look at all those different strata. The grouping of the units composing a population in homogeneous groups, or what you call strata before sampling. I mean, if you go to any population, you will get certain characteristics that are similar. You know, you may have people who are drinking together, schools, churches, people who go to church together, you know, that type of strata. So you classify them in accordance to the stratas that are existing in the population. So this procedure may be used in conjunction with simple random or systematic or cluster sampling. So you can use this procedure in combination with the others, because this improves the representativeness of a sample, at least in terms of the stratification variable. So you look at what makes this community the way it is. So you take those stratification, those stratas, and you put them together. You are stratifying the population. Basically, what it does is so that when you then select, you say, I select from strata A, B, C, D, and all the strata. So every sector of the population may be then represented because you have looked at all those stratas. So stratified random sampling has the advantage of guaranteeing equal representation of each of the identified strata. Now, here we all stand in the population, an equal opportunity of being selected because we have been put together under the stratified random sampling. So it's most appropriate when the strata are roughly equal in size in the overall population. So it is ideal that you put them together in size. They are equal in size, so that as you select one of the strata, you represent the entire strata, and then you take the different stratas in the population, just to make sure that you enhance and improve what is called representativeness of the population. Cluster sampling, almost, you can look at it from a strata perspective, but clusters is where you break the population down into a group of cases. You look at different cases in the population and you break them down so that each case it's identifiable. So cluster sampling may be used when it's either impossible or impractical to compile an exhaustive list of the elements composing the target population. I look at like the SMME. It might be that it's very difficult or impossible or practical to compile an exhaustive list. So what do? You can then cluster them together. I don't know what are the characteristics or the elements of an SMME, but you can look at them and cluster them together, because you may end up with an inexhaustive list of the elements of the target population. So it's ideal at that point to use that. So a multi-stage sampling in which natural groups, or what you call clusters, are sampled initially, with the members of each selected group being sub-sampled afterwards. So you sample them together, you put them together as clusters. So you've already done the sampling, and you then go back and you select, you sub-sample them, those members of the selected group. So you go back to each cluster and you sample them again. So that's the cluster. The last one, ladies and gentlemen, really is the theoretical sampling. Here is where you collect data that's the data that is used for generating theory. The general term of sample that is selected here in terms of theoretical sampling with a probability theory, typically involving some random selection mechanism. So again, it's another probability sampling where you're basing it on the theoretical sampling for data collection for generating theory as a probability sample.
I just want to get to see that I understand clearly between the simple random and the, I think, a stratified random sampling. With the stratified, you say the sample is divided into stratas. Then under each strata, we then do a simple random sampling. Is that what you say?
No, I think I feel tongue twisted there. Repeat the question. I'm trying to. You say you want to understand the stratified.
Yes, the stratified random sampling.
Yes.
You're saying the samples are then divided into stratas. Like maybe on this one, you say you want businesses from youth, and the other strata will be for adults between 35 and 50. The other strata will be males, and then from all the 4, 5, 6, or 7 stratas that you have, you then make sure you do your random sampling from each and every strata.
Oh yeah, I think I hear what you say. Yes, you can do it that way as well, in terms of first classifying them in the different stratas or clusters, whatever whatever will be applicable, and then you can randomly select from each of them, because remember, this is all these different types of probability sampling. Really, it's about random sampling. So just that the other one is simple random, and the other one is systematic random, the other one is cluster random, and the other one is theoretical random, and the other one is more, did I say, clustered, stratified, simple, and systematic. So basically all of them are random.
Oh, okay.
Yeah. So you do it randomly. So the other one, just the simple random, is not the same as the systematic random. So what makes them different is really the systematic, the simple, the cluster, the stratified, and the theoretical. But all of them are random sampling, which will then be representative in nature.
Okay, thank you.
Does it make sense? I hope it makes sense. I did not confuse you.
No, it does make sense. I just want to understand the stratified one, because
yeah, the stratified one, you are absolutely correct when you say you stratify the population in terms of the different stratas that are there. I mean, the big, the medium, there's big in small, there's medium in small, there's small in small, for example. I don't know how it works. There's as you said, I mean, there's age categorization of those that are young people in business and old people and so on. You know, those might be your different stratas, the turnovers and all those kind of, suggestions.
Okay.
Then you've got all of them in the population, and now you want all of those stratas represented. So you randomly select each one of them to represent each cluster or each strata or each theoretical random, whatever the choice that you are following in there. Then every situation or every strata then has an equal chance of being selected and represented in your sample. Then your sample is representative of the entire population of the SMME, if I use SMME as an example. Let's then look at the non-probability. Now, again, remember the idea of research is, if you can understand the technical jargon that applies to every step that you take in, then you've got the concept right. So for example, we were talking about probability. Now, in probability, everyone has an equal chance of being selected because we use random selection there. Now, the non-probability is the opposite. It's a sample that has not been selected using random selection method. So the other one, you use random selection method. This one, you don't use random selection method. So some units in the population are more likely to be selected than others. So here, you will really have those that will be selected, as opposed to everybody standing a chance to be selected. So in non-probability sampling, you as a researcher have no way of predicting or guaranteeing that each element of the population will be represented in the sample. So clearly, some members of the population have little or no chance of being sampled. So not everybody is going to be sampled here. So it's the direct opposite of the non-probability. Please take note, you can use both probability and non-probability in the same study, where you use random, but also you use non-probability and any of the types that are applicable. So you can use both methods, or you can pick one method. So it's still allowed. All what you need to understand is that for your research project, you need to always demonstrate that you do understand the difference between the probability and the non-probability, and you cite sources as you explain yourself on their differentiation as well, because that's quite important. So there's nothing wrong in using a combination of probability and non-probability. You just need to understand them in their own way. And when you mix them, you also need to understand what they mean. Now, in non-probability, we also have types of non-probability sampling designs. We've got purposive, or others will call it judgmental sampling. We've got convenience sampling. We've got snowball sampling, and we've got a quota sample or sampling design. So here, these are the 4 types. Again, you are not limited to the 4. If you go out and you get new types, you're welcome to bring them, and we can slot them into either probability or non-probability, depending on the sources that you are using at the particular time. But these are the 4 that I would like us to have a little chat on briefly. The purposive or the judgmental sampling. Here, this sampling type relies on the researcher's expert judgment to select representative units of the population. So here, you sit and you say, I am simply just going to select certain participants or units of analysis in the units of the population in the entirety. And you yourself now choose who you want them to be participants in your research study. So there's a purpose for which you choose them. You want them for a particular purpose, maybe because the preference could be given to key informants or participants who, on account of their position or experience, have more information or are better able to articulate this information. So you target specific individuals or persons or participants or key informants because they either have, because of their position in the retail sector, or because of their experience in the retail sector, or perhaps they've got more information on retail, or they are better able to articulate the information around retail. So you've got a particular biasness that you'd like them to participate. So sometimes it's appropriate to select a sample on the basis of knowledge of a population, its elements, and purpose of the study. Remember, here you are not necessarily looking for representativeness of the sample. You are just going to select a sample on the basis of knowledge of a population that you probably carry, the elements and the purpose of the study. So people or other units are chosen for a particular purpose. So here you choose us because you've got a particular purpose that you'd like to achieve. May be very appropriate for certain research problem. That is the judgmental sampling. So if you've got a particular research problem that you like to sort of investigate, you may find that perhaps a purposive or a judgmental sampling is a much more appropriate sampling design for your study. So researchers should always provide a rationale explaining why they selected the particular sample of participants. Remember, that is basically what research is about. You always have to justify or provide a rationale on the selection that you are making of the particular sample of participants. So you can't simply, go and identify 10 people and you don't provide the rationale as to why did you go for 10 and why did you select these ones. And as you do so, you justify this empirically by supporting your argument with literature as well. So every step of the way, you make sure that you support your argument with literature. Remember, if you don't do so, you go on and on, we will not know what is it that you're on about. Because in a scientific space, you cite sources or you do referencing of the sources in order to avoid plagiarism. So here you need to make sure as well that you provide rationale, not only for purposive or judgmental sampling, in all the selection that you're making. You always have to provide the rationale as to why are you going for this, unlike for the other. Convenience sampling, for example, also known as accidental sampling. It's very haphazard, fortuitous, and accidental. Here, you select a requisite number from conveniently available cases. So there's enough cases that you've got, and you decide, oh, I'm just gonna select 10 of these cases that are before me. So convenient sampling makes no pretense of identifying a representative subset of a population. It is like it takes people or other units that are readily available. For instance, those arriving on the scene by mere accident, happenstance. So there is an accident has happened, and we all arrive there. So we become conveniently there that, you know, a researcher can talk to us and find out what could have transpired. And on the basis of that, he interviews people and so forth it goes. So convenience sampling may be quite appropriate for some research problems. Again, convenience is also another non-probability sampling designs that may be appropriate for some research problems. So all you have to do is to check what is the problem that you're following and whether you are investigating and whether it's more convenient sampling will be appropriate for that problem or not. Again, ladies and gentlemen, it's not just a question of, oh, I choose this and there's no basis of arguing or providing the rationale. Snowballing, I think we can spend a little bit time here because it's more popular in the retail or in the insurance sector. Now, it's a process of chain referral. Sometimes it's the term chain referral is used in reference to snowball sampling and other similar techniques in which the sample unfolds and grows from an initial selection. I mean, sometimes I'm sure some of you might have been confronted with a caller on the telephone who then says, oh, look, if you like what I'm telling you, do you know of people that might be interested and so forth? So basically what are they trying to do? They're trying to snowball sampling. In other words, they're trying to grow the people that might also be interested in the product, especially in the call centers industry. Some consider snowball sampling to be a form of accidental sampling because you just happen to know one person, and then one person then gives you another person and another person and so on. Then it just grows like that. It's appropriate when the members of a special population are difficult to locate, such as the homeless individuals, the migrant workers, or undocumented immigrants. So in other words, sometimes when you deal with the sensitive information, it's better to look at snowballing because it's more like, you go into somebody by recommendation, rather than just, happening to be there at a certain time, because then there's trust issues and so on. So in snowball sampling, you collect data on the few members of the target population that you can locate, then ask those individuals to provide the information needed to locate other members of that population whom they happen to know. So in other words, you say, well, some people that are undocumented immigrants. Do you know of others that may also I can talk to? So what are you doing? You're just really doing snowballing. Because it results in samples with questionable representativeness. Because remember, you're not necessarily going to have a representative, sample from the population. It's just snowballing according to who I know and who the next person know. So it's used primarily for exploratory purposes. So it's not about representativeness, but it can be used for exploratory purposes. So it's a non-probability sampling method that is often employed in field research, where each person interviewed may be asked to suggest additional people for interviewing. I'm sure some of you have interacted with this method through the calls and so forth and so on. So it might be familiar to most of you on this platform. The other one, ladies and gentlemen, is quota sampling. The quota sampling divides the population into relevant strata. Remember, we spoke about strata earlier. Strata such as age, race, gender, etc. And it does resemble the stratified random sampling. Like probability sampling, quota sampling addresses the issue of representativeness, although the two methods approach the same issue quite differently. And again, here I like using the example of sports because there was a time where there were issues around the rugby, for example, that it doesn't look like it's a representative of South African population. Now, when you look at what they mean is when you look at the rugby team, as it plays overseas or wherever, you don't see that team as a representative of South Africa. What are they talking about? They really say this is how South Africa look like. I mean, there's black people in South Africa, there's Indian people in South Africa, there's colored people, and there's white people. So when they look at the quota sampling, what they say is that you need to look at that population or that team and you see a typical South Africa. So when they were talking about the quota in sports, really they were saying which race is not represented, and therefore if it's not represented, a quota will then say you need to go out and get a certain number of players from that race. What do? You are trying to improve the representativeness of the sample of the population, because then when you look at the rugby team and you see black, colored, Indian, and white, then it looks more like a South African team, just as a state, so as a start. So the quota sampling really was just about trying to get, or when you look at affirmative actions and these other interventions that were there, to increase representativeness in intervention. So quota sampling begins with a matrix or a table describing the characteristics of the target population. So you look at the population in totality, and you then say, well, depending on the research purpose, you may need to know what proportion of the population is male and what proportion of the population is female, as well as knowing what proportion of each gender fall into various age categories, educational level, ethnic groups, etc., and so forth. So basically here what you do, you make sure that each unit of the population is sampled into the study as part of quota. And if it's not there, what you then do is you deliberately go out and identify that quota and you bring it into the sample in order for the sample to look more like to mirror the population, if you like. So it is a type of non-probability sampling in which units are selected into a sample on the basis of the pre-specified characteristics, so that the total sample will have the same distribution of characteristics assumed to exist in the population that is being studied. So when you look at the quota sample, really, it is exactly as it is, that you look at the sampling in which units are selected into a sample on the basis of the pre-specified characteristics. So you do the characteristics of the total population, and then you select the sample from there. Now, then the total sample will have the same distribution of characteristics that exist in the population that you are studying.
Probability sampling and quota sampling and non-probability sampling. Non-probability and Snowball sampling, I tend to confuse the two, non-probability and Snowball sampling.
Okay, I'm saying okay, let's go back to Snowball. What is your understanding of the Snowball sampling? Let's just at least talk to Snowball as a non-probability sampling type. How do you understand?
I confuse it with non-probability because maybe some of the populations won't be represented in Snowball sampling.
No, I don't want you to talk about the confusion, because I don't know why. I'm saying because remember, you are the one who's asking the question that you're confusing one with two. So before we go to the confusion part, let me understand, how do you understand snowball? Remove the random, the simple random for a starters. What is your understanding of the snowball? Because you can only confuse something if you have got an understanding of the two. But I'm saying, I mean, if I go to somebody now and you just talk snowballing and is listening to snowball sampling, they can't confuse that with anything else because they wouldn't know anything else. Edward, I think you're muted. Edward, I think you're muted. Please unmute yourself. Okay, is it me? Maybe I'm the one. Okay, let me check if I'm the one. Maybe I'm the one who's muted.
No, I can hear you. I was just saying non-probability, né? As I understood it, that some of the samplers may not be represented, and that in snowball sampling, it looks like is more similar with non-probability sampling to me.
Yeah, snowball is a non-probability sampling. We agree. But I wanted to you see what I want you to unlock is, what is your understanding of snowball? Leave the other jargon. Let's just throw snowball sampling into the mix without looking at anything else. What is your understanding?
I believe is the sampling with the intention of assuming that it will represent, not being sure, okay, not being accurate, but assuming that somewhere, somehow, it will end up being representative of the sample.
No, that's not snowball. Remember, we said snowball is like chain referral. Right? Are you familiar with the concept there, chain referral, maybe, where they phone you and they say, well, maybe you know one or two guys. Have you been to that kind of a situation?
No, sir.
Where somebody says, oh, I'm selling this product or I'm doing this kind of work. Do you know of anybody who might be interested in it as I've spoken to you? That's what I'm talking about.
Oh, yes.
Have you been in that situation? That's what we're talking about when you say chain referral. You know one, I know. I mean, I'm doing a study for students, and somebody says, well, since you're a student, do you know of other students that I may approach?
Yes.
That is snowball. So in other words, it just snowballs into you know somebody, I know somebody, and before we know it, then a person has spoken to as many as whatever the number might be. Are you following? That's snowball.
Oh, thanks very much. Okay, thanks.
Now that is why we are saying it is appropriate when the members of special population are difficult to locate. So the reason why sometimes it's used is when you're finding it difficult to locate certain individuals or members of the population that you want to interview, such as your homeless. I mean, you can use it on a number of cases: homeless individuals, migrant workers, or undocumented migrants. So as you meet those people and you want to access them, you can use snowball, because one, you happen to meet one that knows another one and another one and another one. So it's more like a chain referral, if you like. Jennifer, go ahead.
Thanks, Prof. Just to maybe to bring this to our level, the honors level, someone help me understand snowball. Maybe this can also help Edward. They say the concept of snowball, it was derived from the snowball itself. The snowball, unfortunately in South Africa, we don't have much of snow, But they say a snowball, it's you make a small ball, but that ball rolls over and over and over until it's a big ball. Meaning you just give information to one person, but that one person will refer you to as many people as possible, because as it rolls, it accumulates a lot of people, and as they accumulate, they make it even bigger. So you just have a small information to one person, but that one person will link you to many other people. I think that's what helped me understand Snowball.
Yeah. Hopefully that helps, Edward. All what it says is, I know, I mean, you're going to talk, I'm going to talk to Jennifer. She's an honor student. Now I want to access UNISA honor students. And after speaking to her, I then ask her, look, this is what I'm doing. And she understands, and she gives me 3 people that she knows that might be interested. And those people each one of them give me 3 people. And I already have, each one give me 3. So I already have 9, and so on. It rolls up to a point where it's like a pyramid scheme. The concept of a pyramid scheme is almost built around that at some point, then you reach a point where some of those names will come back and become the same, at some point. So it's similar along those lines. So when it starts, it rolls, it becomes a small ball. It rolls all the way down, then becomes such a huge ball, and now it can't grow anymore. And then so basically it's just the sampling strategy that they are talking about. As I'm saying, it's more appropriate when you've got the most difficult population that you want to locate. I think Jennifer has really taken you through the origin of the concept as well, and hopefully that then makes more practical sense. Thanks for sharing that, Jennifer.
Yes, I'm thinking the gentleman there perhaps needed to understand that there are 2 different methods of sampling, that is probability and non-probability. But then snowball is one of the methods that falls under non-probability. Because when he started, he said he got confused between the 2. It's like, if maybe I could make it clearer to him, it would be like non-probability would fall under citrus fruits. I'm just giving an example.
Yeah.
And orange would be one of the citrus fruit, meaning snowball can be an orange and citrus fruit can be non-probability. I'm not sure if the confusion was coming from there, because he was referring to them as if they are on same level, of which one is the umbrella one, which is the non-probability, and the snowball falls under the non-probability, and there are many other sampling that falls under non-probability, like the quota you have indicated.
Yeah.
I'm not sure if that could have made a difference. Thank you.
But let me check, Angela. Are you from your side? Because I think Edward did concede after Jennifer clarified. Are you yourself now more clearer? You've got no issues with the different types?
Yes, I don't have anything.
Oh, okay. Because what we are trying to do here really is just to assist you and in the engagement, that you know which type falls under which type of probability or non-probability sampling design. So once you've got that, then you are able to locate where each one falls for the purpose of your own formulation of your proposal. But as to which of the type you want to choose, your research problem will dictate. And if all of us then have that understanding, that may will be sufficient. I'm sorry, I'm just getting a little echo on my side. I can't figure out whether is it a microphone that is not muted. And unfortunately, I don't have any idea where the noise comes from. But let's just see for the purpose of today's session. If you have understood the population, if you have understood the sampling frame, and if you do have an idea of the units of analysis, the sampling guide, the representative sample, and the different sampling types, such as your probability and the non-probability and the types thereof. I think this to me will guide you and assist you as you develop your proposal. And more so, the sampling guide as to numbers, what kind of numbers can we talk to, as we sample from the population. This is more or less what, for me, was the purpose of this engagement. That when we look at sampling, we shouldn't just take it, at face value, but let's rather get more into what it entails and how do we navigate the proposal on probability and non-probability and the different types of the two. So that, to me, ladies and gentlemen, will make us all comfortable if anyone can just use this, so that when we move into the research designs and the validity and the internal validity and reliability measurements, then we know that at least sampling and the population, the units of analysis are done. And it's important in your research to check, what is my population, what is my unit of analysis, and what is my sample, so that you are able to look at those three elements, if not more, to say, do I have a population here? Do I have the units of analysis here? And do I have a sample here? And is my sample representative or not representative? If it is not representative, is the representativeness what I'm looking for, or I'm actually looking for something else? Those are the questions that you can ask just as you go along, just to make sure that your proposal is more tighter and more neater. With that, I just want to give you back and find out if there's more question. Otherwise, this then concludes our session for today. And I give over back to you if you've got any input, comment to raise relating to the sampling and the population issues that we spoke about today. Thank you, everybody for attending, and good night.